Podium is a multi-attribute ranking system for modeling users' subjective preferences. Whereas previous ranking systems require users to quantify attribute weights to derive a ranking, Podium allows users to holistically rank a subset of the data. From those interactions, we derive a set of attribute weights with which to rank the full dataset. The interface is composed of two main panels, the main table and the control panel. The main table represents each data item as a row in the table and each attribute as a column. The primary interaction with the system is to drag and drop rows to define a relative ranking of the data. The relative order of the data interacted with is ultimately used to train the weight solver. The rank score represents the value of each data point with respect to the attribute weight vector. The values are encoded as the width of the bar, and the exact values can be seen on hover. The control panel has buttons for controlling visual parameters in the system as well as deriving and applying the weight model. The Compute Weights button derives a new attribute weight vector using ranking SVM. The user's interactions with the rows in the table are used to form the training tuples. The resulting attribute weights are represented by the size and color of the bars in the Attributes tab. The size of the bar encodes the magnitude of the weight. Positive weights are shown in green and negative weights are shown in red. The Rank button applies the attribute weight vector to the data in the table to compute a new ranking. Training rows whose relative order changed are denoted in the relative rank column. The Minimap tab represents the full table at a glance, showing each row in the table as a horizontal bar encoding the rank score. Now consider the following usage scenario. Anita is a college football fan from Georgia. She wants to use Podium to understand which statistics make her favorite teams successful. She begins by positioning a few of her favorite teams in the table. She drags Florida State and Ohio State up near the top of the table. She does not think Georgia Tech and South Carolina are very good teams, so she drags them below the others. She then finds her favorite team, Georgia, and drags them to the top. She presses Compute Weights to compute an attribute weight vector based on her constraints for the teams and applies the weight vector to the full dataset by pressing Rank. In the control panel, Anita notices most of the offense statistics are weighted positively except for first downs. Lots of first downs should be beneficial for a team, so she toggles the arrow up to emphasize the attribute in the model. Anita then notices that Alabama has been positioned at number 6 in the table. She thinks Alabama is a great team, almost as good as her favorite team, Georgia. She clicks on the row to reinforce Alabama's correct positioning and further refine the ranking model. Anita presses Compute Weights to regenerate the model using the new constraints and presses Rank to apply the resulting weights to the full dataset. In the table, she notices the relative order of the teams is maintained. Ultimately, the model resulted in Georgia at number 3, Alabama at number 5, Ohio State at number 10, Florida State at number 52, Georgia Tech at number 82, and South Carolina at number 96. From her exploration, Anita realizes that her favorite teams are successful due to particularly strong defense that allowed very few points, complete passes, and rushing yards. Offense is generally less important to the success of Anita's favorite teams. Emphasizing offensive first downs changed the weight from -1 to 5% in the final model. Podium allows users to explore their subjective preferences in the data. It can be used to illuminate how individual attributes contribute to a user's understanding of the data. Please read the paper for further explanation on our proposed technique and to see additional usage scenarios.